Where did we stop yesterday? I mean, the previous class. Are you able to listen to me? Are you people there in the class? Are you able to listen to me? I asked you a question. Are you people there in the class? I'm asking you a question. Are you able to hear me?
Yes, ma'am.
What what is happening? I'm asking a question thrice and still I'm not getting a response properly. What is the issue? Are you guys really interested in the class? Or is it like you're done with the final year or something?
Ma'am, assembling stiffness matrix is done, ma'am.
For what?
For in fourth unit, ma'am, isoparametric elements.
Thank you. So only one person was present in the class on that day. Is that so? I'll mark absent for all the others then. From one session to the next session, you don't remember what is told to you and you expect the faculty to tell you everything. I don't understand what is the problem, guys. Do not expect me to give you at least a single important question for your second mid. You're going to prepare it by yourself. I'll make sure of that. I don't know, one session has to be taken for them, sir. Their attendance is very bad. Thank you, sir. All right, let's go forward. So we are done with uh, the equation number 10, that is the stiffness matrix K for isoparametric element. Is it not? Is it equation number 10 that we ended? Switch on your cameras, everybody. I'm not going to do a one-man show here. I have to see you people. I'll mark your attendance and then we'll continue. Switch on your cameras. I said something. Switch on your cameras. If not, I'll cancel the class and unit 4 is done. That's all. $326 present, 19 present, 312, 15 series 106 is present, 17 series 323, 15 series 27, 17 series 309, 15 series 102, 17 series 41. $48, 17 series. 16 series 53,
Yes,
17
ma'am.
series 40, 15 series 106, 45, 17 series 323. So only 15 members are there in the class and attendance is shown for 20. Wow. The numbers that I've noted, only they are going to get the attendance. We'll continue with the class. You can switch it off. Yes, who is this?
Back camera is turning on, ma'am. 324, ma'am.
Ma'am, 91, ma'am.
Who 91? Show yourself.
'91, ma'am.
17 series.
Ma'am, 74, ma'am.
Where are you? Alright, switch off your cameras.
Ma'am, 329.
ఎంతసేపు అయింది వచ్చి 329 అంటున్నారు. You did not switch on your camera or I am able to see you here. Where are you? Show yourself. You have just come. No? You have just come to the class.
Yes, ma'am.
1 hour attendance. Switch it off. I'm sharing the screen now. Please switch off your cameras. We are done. Is this the last thing that we have seen? Equation number 10?
Yes, ma'am.
All right. Did I give you any note after this? After this equation? Or this is the end?
Only
Did I
till
give you?
here.
Sorry?
Only till here we are done, ma'am.
Okay, take a note after this. Integration is to be performed. Integration is to be performed so as to cover the entire area. Integration is to be performed so as to cover the entire area, that is the limit of integration, the limit of integration is from -1 to 1 for xi, -1 to 1 for xi, and -1 to 1 for eta. It is difficult to carry out all the multiplications in the equation number 10, all the multiplications in equation number 10, and then the integrations, It is convenient to opt numerical integration. It is convenient to opt numerical integration. Take down the subheading as numerical integration. Right, from your mathematics, anybody remember what is numerical integration or Gauss quadrature technique or Gauss quadrature formula? All these topics are not new. You have already done in your mathematics. It is just the application of what you have already learned to our finite elements. That's all. So how many members heard what is Gauss quadrature? A yes or a no would do so that we can move forward.
No, ma'am.
Okay. All right. Write down. In FEM, Gauss quadrature is the subheading. Under that, please note down. In FEM, Gauss quadrature formula is preferred since values at n sampling points can be used to fit in 2n minus 1 degree variation. 2n minus 1 degree variation. The numerical integration in this method The numerical integration in this method is achieved by the expression right. This is the expression. Integration minus 1 to 1. That is our limit of integration. We have seen it already. Function of xi into partial differentiation of xi will be equal to summation of I is equal to 1 to n samples wi into function of xi I. Let us take this as equation number 11. Are you able to see the equation clearly now?
Yes.
Yeah. Where wi where wi weighting function, wi is the weighting function, f of xi I, values of functions at predetermined sample points, at predetermined sample points. Under which we have another xi I. Xi I indicates Gauss points. Please give me a yes once you have noted this down.
Yes, ma'am.
Okay.
Yes, ma'am.
Thank you. Take a point after this. In Gauss quadrature formula, points are clearly placed. Points are, my mistake, it's cleverly placed. In Gauss quadrature formula, points are cleverly placed. Both n sampling points and n weights weights indicates weighting points or weighting functions. Okay, n weights are treated as variables to make exact 2n-1 degree polynomial. The location of sampling points, the location of sampling points, the location of sampling points. Here sampling points means the Gauss points, okay? The location of sampling points xi I and weight function wi are determined using Lagrange's polynomials. Lagrange's polynomials. Therefore, sometimes this method is termed as Gauss-Lagrange's quadrature formula. For example, let us take a 2D problem. When we take a 2D problem, what happens? N is equal to 2. So what happens? We will have two by two Gauss points. Okay. Let us take for the ideal rectangular member what we have seen till now. Okay. Xi eta. And what do we have? 1 minus 1 minus 1 minus 1 1 comma 1 minus 1 1. This is the four noded rectangular element with taken under natural coordinate system. All right, for this there are 4 Gauss points. I'll enlarge this a little so that you can see the picture clearly. Right. Xi 1, eta 1, Xi 2, eta 1, Xi 2, eta 2, Xi 1, eta 1. For this, the Gauss-Lagrange's quadrature formula will be integration of minus 1 to 1 and again for 1 for xi, 1 for eta. Okay. Function of xi comma eta d xi d eta will be equal to I is equal to 1 to n wi f of xi comma eta d eta. First we have removed xi and now term for eta. J is equal to 1 to n weighting function j, excuse me, 1 to n wi function of xi comma eta. First we have integrated for xi, next we have integrated for eta. Okay, the whole equation can be rewritten as integration of minus 1 to 1, integration of minus 1 to 1 function of xi comma eta d xi d eta will be equal to summation of j is equal to 1 to n summation of I is equal to 1 to n. This is not eta, okay, that is n wj wi function of comma eta. This is the Gauss quadrature formula. Gauss quadrature formula. If you refer your textbook, for what points of xi I, that is the sampling points, what points of wi or wj, that is the weight functions, have to be taken, there is a table already given. All right, predefined table is there. You can refer your textbook for that. All right. So this ends the whole derivations that are there in our unit 4. If we check out for 2 to 3 problems, that will be the end of the unit. But I want there is another topic, that is shape functions for a 8-noded parabolic curved isoparametric element. All right, that we will see when after completing few problems. All right, excuse me. All your calcs, keep your calcs ready with you. We'll start with the problems now. All right, I want answers from your side. I'm not going to solve it on the board. You're going to solve it and give me the answer. I'm just going to give you the question. Okay, right. Determine Cartesian coordinates determine Cartesian coordinates of point P xi is equal to 0.5, eta is equal to 0.6 for the element shown in the figure. For the element shown in the figure. Two comma 1, 8 comma 3, 7 comma 7, 3 comma 5. For this, the natural coordinate system goes like eta and xi. Here is the point P. Will you take down the figure? Did you take down the figure?
Yes, ma'am.
Okay. We have points given xi comma eta, right? Now here what is asked for us to find out? We have to find out the Cartesian coordinates of the point P for the same P which is given in natural coordinate system. The coordinates of the same point in the Cartesian coordinate system. That is, they are asking us to find out x comma y of this point P. P x comma y. This is what we have to find out. If you check your notes back, it is clearly given how to relate the shape functions which are used for the nodal displacements for the geometry. That is what we were doing in the isoparametric concept. All right. So we have equations for x and y with respect to shape functions. You have to turn back your notes, then only you will be able to remember what I'm talking. All right. There are equations where x is equal to sigma nixi, y is equal to sigma niyi. Did you see these equations anywhere already? You have to check back to your formulas, derivations what we have seen. So we need these equation to get what is the Cartesian coordinates of the point P. Now what we have the vertices xi, that is here it is 4, it is a quadrilateral, so I is equal to 1 to 4. I is equal to 1 to 4. Alright, so x1, y1, x2, y2, x3, y3, x4, y4 are already there from the figure, the vertices of the element. Alright, so what do we don't have are the shape functions. So how are we going to get the shape functions? Turn on the shape functions formulas. Shape functions formula. Are you guys there in the class? Or I'm alone again? Shape functions for a four-noded rectangular element, taking that as the parent element, we have already done the mapped element. Right? We got the values of shape functions to be the same of the parent element. So what is n1 here? n1 is 1 minus xi 1 minus eta divided by 4. Is it not?
Yes, ma'am.
Solve all the values for shape functions and give me what are the four shape functions. You people are taking so long. Shape functions are directly available. You just have to substitute the values of xi and eta. If you take so much time to solve, no, you cannot finish your problems in your external exam.
0.15.
Which one?
N2, ma'am.
Okay. Right? N3?
0.6.
Right. N4?
0.2.
Right. Good. You have the shape function values also now. You have to find out x and y. You have all the values with you. I is equal to 1 to 4, ni xi. Start solving. n1. First one, n1 into x1. n1 is 0.05. What is x1? 2. n2 into x2. n3 into x3. n4 into x4. You have to find out the value of x, then also y. Tell me the answer. I've given you the equation on screen. Like that, you have to find out for y also. ni into y. ni into yi. Tell me the answers for x and y. These are just 2 marks problems. You cannot take so long for this. Who is that?
6.1 and 5.7.
Which is 6.1?
X, ma'am.
X is 6.1. What is Y?
5.7.
Very good. So the Cartesian coordinates for the point P are 6.1 and 5.7. How many members got the answer? How many members got the answer? (6.1) and 5.7. How many members got the answer? अरे बाप रे. Please respond. If I wait, it's you, the people will comment that I'm going very slow. If I do not wait and go for the next topics, you people will tell I'm going fast. All the words are from your side. What do you want me to do? I'm really clueless.
Got answer, ma'am.
Thank you. Note on the next problem. Whoever wants to do can do it. These are node 1, node 2, node 3 and node 4. This we have psi comma eta and some point q which is 7 comma 4. Here the question is, for the isoparametric quadrilateral element shown in the figure, determine the local coordinates for the point Q whose Cartesian coordinates are 7 comma 4. Whose Cartesian coordinates are 7 comma 4. The same technique what we have done in the previous problem, but x and y are given to us now. We have to find out xi and eta. Same shape functions formula, same x comma y formula. Start solving. I need the answer for xi and eta from your side. I am not going to do anything. It's you who's going to solve it. You have to give me what is the answer for xi and what is the answer for eta. That's all. Did you at least start doing it? You will get two equations with xi and eta, which you have to solve it in the end to get that. Anyone? Equation number 1, which you will get from x equation. Anybody? Are you able to hear me? Guys, are you people there in the class?
Yes, ma'am.
Equation number 1, which you will get from x equation. Reduce this equation, solve it. You will get one equation. Anybody? You took so long, you still didn't reach to this point. X value is given to us. What is x? X is 7. We have another problem to solve. For 2 marks problem, you're taking so long. Anyone who got this equation? Equation number A. After solving the x formula. At least one member. If it is a no, please tell a no, guys. "22 members in the class. Still such a silence. So much of silence is not seen when you people are actually there in the class, offline. Soil mechanics lab. Are you people going to respond or shall I end the class? This is not happening. You're literally bringing me on nerves.
Ma'am, please wait. We are doing, ma'am.
At least tell that. No, you didn't get. At least you can tell me that. I'm keep on shouting whether did you get it, did not, you did get it or not. I'm asking. At least tell her no. So how much more time you think it needs? We have a bigger problem to solve. ల్యాబ్లో ఉంటారు.
Ma'am, we are getting in points now, ma'am, equation.
Which points? Which equations you're telling? After solving?
Ma'am, this A and B equations.
Huh? What happened
And
in A and B equation?
ma'am, in Y equation, I got 2.75 plus 0.25 plus 0.25, like that I got, ma'am.
What equation did you get?
Y equation, ma'am.
Next equation you're talking about, equation number B?
Yes, ma'am.
This will be equation number B.
Yes, ma'am, correct.
Continue. Solve for xi and eta and give me the values of xi and eta. So only Chandana Priyanka got that, or how about others?
Solving, ma'am.
Okay, do it. I'll give you 5 more minutes, that's all, because we have another problem to solve which is expected to be an external 10 marks question. And we don't have much time. You're taking so long for 2 marks problem. Use calculators to solve it. You're putting each and everything on the paper and you're taking so long. Are you people not using your calculators?
Ma'am, size 0.913.
Which one? Xi.
Xi, ma'am.
Okay, 0.91.
913.
Very
3.
good. Right. 0.91255 or something you'll get. Good.
Yes, ma'am.
Xi.
Liter 0.2105, ma'am.
Right. Very good. 0.2105. So let us take this also in another decimal. 9125. So this is xi comma eta. Very good. Others? Question number 3. I'll only start the question. You'll have to complete it. Okay, I'll tell you how the process goes, and this will be your solution. After this, I'll give you a problem in the next class, or through WhatsApp, or in the file section, which will be your assignment question for unit 4. Okay, for unit 3, already 2 assignment questions are given. Take down the question, please. Consider the rectangular element. Consider the rectangular element shown in the figure Assume plane stress condition. Assume plane stress condition. Taking E is equal to E is equal to why is it not coming? Thirty into 10 to the power 6. 30 into 10 to the power 6 pound per square inch. Mu is equal to 0.3. Mu is equal to 0.3. Yes, somebody have to tell anything? And elemental displacement matrix delta E is equal to 0, 0, 0.002, 0.003, 0.006, 0.0032, 0, 0. Evaluate J matrix, that is Jacobian matrix. J matrix, B matrix. What is B matrix? What is B matrix? Yes, I'm asking you something. What is B matrix? Are you guys there in the class? What is B matrix? I'm just asking its name. I didn't ask you to solve anything yet. What is B matrix?
Strain displacement.
Thank you. Why did you take so long to answer that?
I thought it's wrong.
You have to answer. I'm there to tell you if it is wrong or right. Oh. All right, take down the figure. Here Q1, Q2, Q3, Q4 are all the displacements happening. All right. So what will this become? This is U1, V1, U2, V2, U3, V3, U4, V4. All right. So evaluate what J matrix, B matrix, and sigma matrix. Evaluate J matrix, B matrix, and sigma matrix at xi is equal to 0 and eta is equal to 0. That is the point. Xi is equal to 0, natural coordinates, at xi comma eta is equal to 0 comma 0. Now first we have to find out the Jacobian matrix. So what terms do we have in Jacobian matrix? What terms do we have in Jacobian matrix? Go back to derivation and see what is Jacobian matrix. Partial differentiation of shape functions with respect to xi and eta multiplied with x or y terms. That is what you have in Jacobian matrix, is it not? I'm asking you something, guys. You need not always answer a yes. At least you can tell me you are searching or you did not find, or you, at least you were absent for the last class. All right. From your derivations, what we have seen previously, check what is Jacobian matrix, check what is strain displacement matrix, check what is sigma matrix, solve the problem, and come back for the next class. I'm closing the session now. Tomorrow morning, again 9:30 to 11:30, we have the class. I need you people to come to the class with the solution of this problem. If not, don't come. Keep on shouting and keep on shouting. You people are quiet. What do you think? Am I free here to sit and take the class for you? No response, nothing. When such silence is asked to maintain in the offline class, no. Solve the question, then only enter the class tomorrow. Without the solution, please do not enter.